Okay, second part of the video, C6 electrolysis test. This is question 3F onwards. Here you're asked to calculate the percentage of bauxite that's converted into aluminium oxide. And that is done by taking the 2,500 kilograms of bauxite and the 1,950 kilograms of aluminium. You work out the percentage that 1,950 is of 2,500. So 1950 divided by 2,500 multiplied by 100 to give a percentage is 78%. Okay, so it's simple mathematics. All you need to do, the hardest part of this, is to extract the correct information from your flow diagram. Okay, next one. Calculation. Now this one looks much worse than it is. Just a few simple steps here. So show by calculation. The mass of aluminium produced is less than that expected from 1,950 kilograms of aluminium oxide. So what they're saying here is, if you take 1,950 kilograms of aluminium oxide, you take all the aluminium out, it should be more than 1,000 kilograms, okay? They want you to prove it. So we do that by firstly looking at the relative formula mass of aluminium oxide. We do that by adding the masses of all of these together. So 2 aluminium, 3 oxygen, so that's 54 and 48, which totals 102 grams. Okay, second step, the percentage of aluminium in aluminium oxide. This is 54, which is your 2 aluminium, and you divide that by the formula mass, which we worked out as 102, multiply it by 100 to get a percentage, gives us 52.9. So then we look at the 1,950 originally in the question here of aluminium oxide. We multiply that by 52.9%. And that should give us something in excess of 1,950 divided by, multiplied by 0.529 equals 1,031.55. So we've proved that we should actually get more than 1,000 kilograms from 1,950 kilograms of aluminium oxide. Okay, next question. Figure 1 here shows the apparatus used to electrolyze silver nitrate. So in this case, they're asking for slightly more challenging information. So name of the product discharged at each electrode. Write half equation for the reaction at each electrode. The product at the negative electrode, which will be the positive ion, is going to be silver. Okay. The half equation is Ag+, which is the ion. It's aqueous, plus, aqueous here. We know it's aqueous because it tells us it's in solution, so it's dissolved. And we add electrons to it to make it silver solid. Okay. On the other electrode, we produce oxygen. Now, remember the rule. If there's a halide in there, the halide is always given off first. But there is no halide here, there's nitrate, and it's in solution, so water's there, so it must be oxygen that's given off, okay? So you pick up the mark just for knowing that. Now the more complicated thing here is the half equation at the positive electrode. We've got 4 hydroxide ions, and these come from the water. So we have OH- ions, we have H+ ions. And this produces 2 oxygen, 2 water, and 4 electrons. Okay, so if you can imagine, if we have 4 OH- ions, and the hydrogen from here joins there, the hydrogen from there joins there, it's going to give us oxygen and 2 water molecules, okay, which is what we've got here. Okay. That one is more complicated. You would do well to try and remember that one. Okay, it takes a little bit of working out. So try and remember that one. Okay, another electrolysis, this time sodium chloride solution. So again, use the information they give you, it's solution. So we know water's in there, okay? So the ions involved here are Na+, Cl-, OH-, and H+, okay? They give some information about concentration of sodium chloride solution, and as that changes, the volume of hydrogen gas that is produced. So that's what's measured. So this is the dependent variable, the thing that's measured. This is the independent variable, the thing that we choose to change. Then they ask us to plot the data from the table on figure 2. So we've got to make sure we label the axis, both X and Y. Well, I've done that here. Independent variable goes on the bottom. So that's the concentration of sodium chloride and the units, okay? And the volume of hydrogen gas in centimeters cubed goes vertically, okay, up that way, because that's the dependent variable. Use suitable scales. So I use the information here to indicate I went up to 100 in total here for the concentration, and I went up to 10 for the volume of gas. Okay, so I knew that I had scope to include all of those figures. And then I plotted those. Now, to get the marks, you have to plot these within 0.5 of a square. So they've got to be very, very accurate. They want a line of best fit. So here we can see all of those fit the line of best fit. We've got one anomalous result, which we can see here, just falls slightly south. Okay. Describe the trend on your graph. So here we're describing, we're not explaining, we're just saying what we see. So as the concentration of sodium chloride increases, the volume of gas, hydrogen gas, also increases proportionally. Okay, so as the concentration of NaCl increases, the volume of H2 increases. Part C, give the dependent variable and the independent variable. So as I said before, the thing that we measure is the volume of H2, and the independent variable is the concentration of sodium chloride. And the last part now. Explain how chlorine gas is produced at the positive electrode. Chlorine ions are aqueous. They're attracted to the positive electrode. So that's the first thing you need to say. Okay. When those ions get to the electrode, the chlorine ions discharge or lose an electron. The chlorine atoms then bond together to form Cl2. You could say that's covalent bonding. Okay, non-metal, non-metal. And then give the half equation. Balance it. 2Cl minus aqueous, give us chlorine gas and 2 electrons. Okay. And part E. Sodium ions and hydrogen ions are attracted to the negative electrode. Why is hydrogen gas produced at the negative electrode? Well, that's because hydrogen is less reactive, so it's given off first. Okay, so the least reactive positive ion is always given off first. Okay, hope that's helped, folks. Go through your notes, check all those, and give yourself a percentage. Email me the percentage, I can put them on the system. Thank you. Bye.